Alright, so here's video 2 for starting with question 19. So here we are, we've got x minus y, we're graphing inequalities and shading. So we've got x minus y less than or equal to negative 1. Then we're going to, this is a standard form, so we need to get it in slope-intercept form, which is y equals mx plus b. So I need to move my x over to this side. So I'm going to subtract x from both sides, and I get negative y, because these cancel each other out, less than or equal to, I cannot combine these two, minus x minus 1. Now I've got a negative y, so I need to divide by negative 1 to get rid of that negative in front of my y. When I do that, I need to flip my sign. So my sign, which used to be less than or equal to, now becomes greater than or equal to. These, a negative over negative is a positive, a negative over a negative is a positive, a negative over a negative is a positive. So here's my new equation. So I'm going to go up to positive 1. My slope is 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, or I could go down 1 to the left, negative, 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 as long as in this situation both are the same sign, both positive or both negative will both give me a positive slope. So there you have it. Now I need to shade, and so y is greater than, y is going up, y has to be bigger than the rest of that. So I know that I'm going to shade up here. And again, I can plug in a very simple xy value to see if it makes sense. If I were to take, say, negative 2, 2, negative 2, 2, which would be that point, that should make this equation correct. I'm not going to put it in this equation, I'm going to put it in the original equation, because if I did a mistake, I want it to make sure that it fits in this equation. So I plug in my x. If this is my x and this is my y, I'd have negative 2 minus 2. That should be less than or equal to negative 1. Negative 4 is actually less than or equal to negative 1. So that is correct. Oops, sorry. Little ladybug on there. Alright, moving on. Number 20, we've got, now we're going to solve the equations by graphing. So all I'm going to do is take both of these, I'm going to graph them, and I'm going to find where they intersect. Where they intersect is where there is a solution for both of those lines. We're trying to find out which x and y value would fit into both of those equations, and that is the point of intersection. So if this is my y equals mx plus b, my y-intercept is positive 4, my slope is negative 8, so I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8, and my run is positive 1 because it's a negative, so I have to have a negative and a positive. So here is this line. Now for the next line, I'm going to start at negative 3, and my slope is a negative 1. So I'm going to go down 1, positive 1. And look at that. So here is the point of intersection is positive 1, negative 4. That's my x, that's my y. That's where they meet up. Moving on. So now, same type of thing. I'm just going to graph these. This is my y-intercept, my slope. This would be my rise. This would be my run. There is a negative, so that means one is negative, the other is positive. Either one can be negative or positive. Since I'm at the top of my graph, I'm going to go down 8. I'm going to use my negative as an 8. 1, 2, 3, 4, 5, 6, 7, 8, and then positive 3. 1, 2, 3. And I'm going to graph. And my next one is going to be, so that's done that line. Now I'm going to go to negative 3. If this is my rise, this is my run. Again, it's negative, which means that one has to be negative and the other has to be positive. I'm going to do my negative at the top on my rise and my positive on my run. So I'm going to go down 1 and over 1, 2, 3. And look at that. They intersect right there. Now, if I wanted to check my work, which I highly recommend you do, so my point here, first of all, my point here is 3, negative 4. If I wanted to check my work, what I could do is take those numbers and plug it in to both of these equations, and they should be correct. So I'm going to just do this real quick. If I were to put 3 in for my x, 3 times negative 8 thirds is going to give me, well, here, I'll do it for you. So negative 8 thirds times 3, which is my x, plus 4. This is going to cross each other out. Negative 8 plus 4, that should equal my y. Negative 4 is my y, and that's negative 4. This is my x, this is my y. So that checks out. It should also check out here. Negative 4 should equal negative 1 over 3 times 3 as my x, minus 3. This is my y, this is my x, this is my x, this is my y. So I get negative 4 equals, these cross each other out, negative 1 minus 3, negative 4 equals negative 4. So that checks out. So now I know I've got it correct. Alright, moving on. If I have here y equals 2, why are your arms out like that? I know it goes like this. Here's my y equals 2. Then this is in this is in standard form, so I need to create it into slope-intercept form. So 2x minus y equals 4. I'm going to subtract 2x from both sides, and I get negative y equals, I cannot combine these two because one's an x and one's a whole number, so negative 2x plus 4, but this has a negative in front of it. So I need to get rid of that negative. I'm going to divide everything by negative 1. And I get positive y equals, negative over a negative is a positive, 2x. A positive over a negative is a negative. So this is my y equals mx plus b. My b is my y-intercept, so I'm going to go down to my y-intercept, which is negative 4. My slope is the number in front of my x, so I'm going to go up 2 over 1. It's positive, so this has to be positive, that has to be positive. Up 2 over 1. Up 2 over 1. Now, since y equals 2, any ordered pair would have a 2 as my y. I could have gone ahead and written 2 as my y because I know y is going to always equal 2. And if these two lines are going to cross, y is going to have to be 2. I knew that that was going to be there even before I started. Well, once I saw this. So the point of intersection is 3, 2. This is my x. Okay. Now we've got two lines, both in standard form, and we've got, so we need to transfer them into slope-intercept form. So I've got y, 2x plus y equals negative 4. I'm going to subtract 2x from both sides. And I'm going to get y equals negative 2x minus 4. Then the next time, I've got 2x plus y equals 4. So I'm going to subtract 2x from both sides, and I get these cancel each other out, and I get y equals negative 2x plus 4. Okay, I'm starting to see something, but don't do it until you graph it, because part of the answer is by graphing. It says solve each system by graphing. So if you just answer the solution, you need to show me the graph. So I'm going to go on my red line, I'm going to go to positive 4, and my slope is negative 2, so I'm going to go down 2 over 1. Down 2 over 1. So here is my line for the red equation. Then for my purple equation, I start at negative 4, and I've got a negative slope here. However, if I go down, it's going to be off my graph. And I know that if I have a negative, I can go up to, that's positive as long as I go to the left one, because that would be a negative. That would be a positive over a negative. And a positive over a negative is still going to give me a negative. So it's going to look like this. And what do I see? I see that these two lines had the same slope. The slope was both negative 2, and since they have the same slope, they're parallel, and there is no solution for parallel lines. Okay, they will never ever intersect. Okay, number 24. So now we have inequalities. We're going to sketch and shade and figure out what is the common shaded portion of these solutions. So the first one, I'm going to do in purple. My y-intercept is negative 3. My slope is 6. So I'll go up 6. 1, 2, 3, 4, 5, 6 is my rise. Positive 1 is my positive, and positive gives me a positive slope. And I'm going to use a solid line because it's equals to, so I can use a solid line. Then I'm going to, y is greater than, so I'm going to graph, or I'm going to shade, since y is getting bigger. Y is bigger than anything on the side of the graph, or the side of the line. So I'm going to shade this portion. My next line I'll do in red, and I'm going to go up to 2, and because that's my y-intercept, my slope is 1 over 1, so 1 over 1, 1 over 1, I up and up, positive, positive, or negative, 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 and I get, and this time I'm going to do a dashed line because it is not equal to, it's only greater than. So I see that the part that I would shade in here is above also, it's above. It also includes that tiny little area that the other one didn't. So the point of solution is actually just from here, this portion right here. That's the only part that needed to be shaded in. That is your solution. And again, a way to figure that out is to pick a point in here and plug it in and see if it actually works out to satisfy both equations. Number 25, we're going to graph this. This is my y-intercept. My slope is 1 over 1, 1 over 1, 1 over 1. Positive, 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 or negative, 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 negative. Guess that's kind of, alright, like, and I'm going to use the solid line. Boom. And I need to then now shade above because this is a greater than, so y is getting bigger, so anything y has to be bigger than anything on that line. That's my phone. Alright, so then we're going to go ahead and graph this line. If we go down to -3, my slope is -4. So I can't go down, and we know that if we do a positive, then we've got to go a negative this way. So we're going to go 1, 2, 3, 4, and a negative that way. So then I can graph that. I'm going to look, and I've got a dashed line because it is, I'm sorry, it's a solid line because it's a equal to, so I can do a solid line like that, equal, and now I see that y is less than, so I'm going to highlight less than. It would include all of this, but the solution area is just the part where both would be included. This whole thing would be shaded, but the only part that's solution is the highlighted portion, because that's the only portion that would satisfy both of these equations. Alright, hopefully that makes sense. Moving on. Now we've got a y is greater than 3. So we know, why are your arms stretched out like this? Why are your arms out like that? I don't know. So I'm going to go up to 3, and I'm going to do a dashed line because it's not equal to. So I'm going to do a dashed line. So there's that one. Then the next one I need to put into y-intercept form. So I've got 2x plus y less than or equal to 1. I'm going to subtract 2x because I've got to get that y by itself. Y is less than or equal to negative 2x plus 1. You see that? So I'm going to go to positive 1, which is my y-intercept. My slope is negative 2. So my negative 1, 2, positive, or a positive over a negative. Oh, I forgot to shade that other one. Now, this one I'm going to do a solid line because it is equal to, and now I need to shade. This one is less than, so I'm going to shade below here. This one is also less than, so it'd be everything below here. So the only shaded portion would be that. Do you see that? If I were to shade, I would also shade this in purple and this in red, but that would not be a solution. That would only be a solution for those specific lines. Does that make sense? The only part that is shaded in yellow is the combination part, because if I were to shade all of this or all of this, the only part that's shaded by both is the highlighted portion. Now, the Jayden French right here, is that a solution? No, it's not, because this is a dashed line. So that is not a solution for this dashed line, and it has to be a solution for both. So there you go. Shout out to her. Okay, what about here? We've got two in standard form. We've got to move this into slope-intercept form. So we are going to take x plus y greater than negative 3, subtract x. Y is going to be greater than negative x minus 3. When I graph that, I'm going to go down to 3. My slope is negative 1 over 1, so down 1, down a negative over a positive, or up a positive over a negative. Both work for a negative slope. I need to do a dashed line because it is not equal to, just greater than. So my shading would be above because it's greater than. My y is getting greater than. My next line would be 2x minus y less than negative 3. I'm going to subtract 2x from both sides. Kind of treat this as an equal sign. And these cancel out. Negative y greater than negative 2x minus 3. But we've got, ooh, sorry, that is totally off the screen. Here we go. Hopefully you got all that. So I took this, put it up here, subtracted 2x from both sides, but now I've got a negative. So I've got to divide by a negative 1, negative 1, negative 1. If it was an equal sign, it wouldn't make a difference. However, when we have an inequality, we know we take that sign and we flip it the other way. Negative over negative is a positive. Negative over negative is a positive. So here's my new equation for the red line. Go to positive 3. My slope is 2 over 1. Positive, positive, or negative, negative. Down negative 2 over negative 1. I can do that because a negative over a negative is a positive. It's going to be a dashed line because it's not equal to, so I'm going to dash my line. That indicates that the solutions on that line are not part of that. And I know that it's greater than, so I'm going to shade above the line. So the only portion that is a solution to both of those lines would be this highlighted area right here. Okay, those are the only solutions. You can pick a point in there and plug it in, and that will provide you with, if I was going to do that, let's just pick a point. Let's just do negative 2, positive 2. And does that work? So x plus y greater than negative 3. Negative 2 plus positive 2, if this is my x and this is my y. Is that greater than negative 3? 0 is greater than negative 3. So check, that one works. We've checked that. What about the next one? 2x minus y greater than negative 3. I'm just checking my work. I've picked a point, a random point within the shaded area. I'm plugging my x, my random shaded negative 2, 2. I'm just saying, if this fits into both equations, then I know that I've shaded the correct area. That's what I'm doing right now. So if this is my x and this is my y, 2 times negative 2 minus 2, is that actually greater than or less than negative 3? Negative 4 minus 2, is that actually less than negative 3? Negative 6 is less than negative 3, so yes, I've checked that one as well. That's how you check your work on these. Okay, moving on. Now we're going to be solving inequalities with the graphing on a number line like this. So we actually have to work the problem, solve for m, and then shade in the number line. So again, the way we start these is we kind of go back as if this were an equal sign, and we're going to use our distribute, combine like terms, and then inverse operations. Inverse operations. So I'm going to take my equation and I'm going to distribute is my first step. 5 times 1 is 5, minus 5 times negative 2m is minus 10m. I'm going to basically treat this as an equal sign, but I'm going to keep it like that so that I don't get confused. Then I need to distribute this side. 7 times 11 is 77, minus 7 times 49 is 7 is 49m, plus 3m. So over here I don't have any combined like terms. All my terms are different, so I can't combine them. Over here I've got two terms that need to be combined. This one has an m and this one has an m. So when I combine them, I did nothing to this side, so I'm going to leave that side the same. I've done nothing to the 77, but when I combine these, I'm going to get negative 46m. Now I can start moving my stuff because I can't combine anything over here, I can't combine any over here, so now I start using my inverse operations. I'm on to step 3. So to do that, let's add 46m to both sides. And I get 5 plus 36m greater than or equal to 77, because these cancel each other out. So then, I get another piece of paper. I'm going to, here we go. Now I can subtract 5 from both sides. Use my inverse operations, 5 being added to 36m, and so I subtract it, so I get 36m on the side, greater than or less than 77 minus 5 is 72. Now 36 is being multiplied by m, so to use my inverse operations, I'd now have to do the opposite of multiply, which is divide. Before I was just adding and subtracting. Now I have to divide because we're being multiplied. This crosses out to give me m greater than or equal to 72 divided by 36 is 2. So m is greater than or equal to 2. Since it's greater than or equal to, I'm going to use a closed dot on my 2. I use a solid dot, just like how up here I used a solid line when it was less than or equal to. I use a solid dot. So m is greater than, so I'm going to highlight the portion that m is bigger. M is getting bigger. It has to be bigger than 2. That is bigger. 3, 4, 5, those are all bigger than 2. Okay, next I'm going to distribute. First thing I do is distribute. Step 1, distribute. So I distribute my 8 to both of those in the parentheses. I get 8x minus 8. I bring down my greater than 4. I don't do anything with 4. Minus. And when I distribute this 2, I need to make sure I'm distributing my negative with it. So negative 2 times x is negative 2x. Negative 2 times positive 1 is negative 2. Make sure I distribute my m sign correctly. So now I've got nothing to combine over here, 8x minus 8. But I do have 4 and 2 that I can combine, this little 4 and this little 2. So I get greater than 4 minus 2 is 2 minus 2x. So now I've done my distribution, I've done my combined like terms, now I'm on to my inverse operation because I can't do anything else here. So let's add 2x, and I get 10x minus 8 greater than 2. So I'm going to bring that over here because I'm running out of room. 10x minus 8 greater than 2. So let's add 8 because I got to get that 8 over on the other side. And I have to balance my equation. I can't do, I have to do one side, I have to do the other side of the sign. So I get 10x, these cancel each other out, greater than 10. Now I'm going to divide by 10 my inverse operation since 10 is being multiplied by x. Sorry again about that. Since 10 is being multiplied by x, I have to divide by 10. Divide by 10. cross that out. X is going to be greater than 1. So in order to graph that, it's not greater than or equal to, it's just greater than. So I'm going to up here use an open dot. Just like up here we used a dashed line to show open spaces. We're using an open dot to show the open space. That 1 is not included in this, in our solution. Because 1 is not greater than 1. 1 is 1. 1 is equal to 1. So if 1's not greater than 1, then it cannot be included. So x has to be greater than 1, so we include all the greater than numbers. 2 is greater than 1, 3 is greater than 1, 4 is greater than 1. All of those numbers that I've highlighted would make this equation correct. Alright, moving on. Now, what's my first step when I have a problem like this? Distribute. That is the first thing I do, so I'm going to distribute. I get negative 10m plus 3 times 8 is 24m. 3 times negative 6 is minus 18. Less than or equal to 8. Oh, sorry. Oops. Boom. Mistake. 8 times 3m is 24m. Plus 8 times 4 is 32. Alright? So this is as far as I can go over here, but I do see some like terms over here. There's a number with an m and another number with an m. So I need to combine those up. I just take them and mush them together. They're already, all I do is I take them and I mush them together. So negative 10m plus 24m is going to give me 14m minus 18. 24m plus 32. I don't do anything else. So now I've distributed, I've combined my like terms. Step 3 is inverse operations. Not until I'm done doing distributing and combining my like terms do I get to start adding and subtracting from both sides. So let's take, I like to keep my m's positive, so in order to keep that positive, I see that 14 is less than 24. So I'm going to take the 14 and move it over to this side. So I'm going to take my 14m and I'm going to move it over to this side in hopes to keep my m positive. And I'm going to get, this cancels each other out, negative 18 less than or equal to 10m plus 32. Now, I've got to move my 32 over to this side because that's, I've got my m over here. Now all my m's are on one side. I got to get my numbers on the other side. So I'm going to move my 32 over here because I'm trying to get everything simplified. When I do that, negative 18 minus 32 is going to give me negative 50 less than or equal to 10m. Then when I divide, okay, so I've used my inverse operations. This was being added, so then I had to subtract. That's the opposite of adding. Now I'm being multiplied, so now I use the inverse operations to division. And I get negative 5 less than or equal to m. So now since I have a less than or equal to, I'm going to use a solid dot because of that equal to sign. And I'm going to put that right on that negative 5. M is greater than negative 5, so I need to make sure that I highlight 0 is greater than negative 5, 1 is greater than negative 5, 2 is greater than negative 5, so I know I'm going to highlight this way. Alright. Next, let's same stuff. Distribute, combine like terms, inverse operation. 3n minus 1 plus 3n greater than or equal to. Now, there's no number here, but I still need to distribute because there is a negative sign, which means that there is a -1. That -1 is going to be very important. So -1 times 2n is -2n. -1 times 5 is -5. Plus, now I can distribute this. 2 times 3n is 6n. 2 times 8 is 16. Ta-da! However, I've got to combine like terms on both sides. I've got this and this. Got this and this. And I've got this and this. So, I've got lots of terms that I need to combine. 3n plus 3n is 6n. Make sure that that negative only sticks with that 1. That's 6n less than or equal to -2n plus 6n is going to give me 4n. So those are all combined. All my n's are combined. Now I've got to take my whole numbers. And I've got -5 plus 16. That's going to give me positive 11. Alright. So now I've combined all my like terms. I'm down to my very simplified form. So now it's time for me to use inverse operations to actually solve for n and get n by itself. So to get n by itself, I see that 4 is smaller than 6, so I'm going to move. Sometimes you can't keep n positive, or sometimes you do something and you can't keep n positive, and that's okay. But and if you like to keep n on the same side of the equation, that's okay too. Just know that if you're going to get a negative n, you have to flip your sign. But it's okay whichever way you go. So 6n minus 4n is 2n minus 1 less than or equal to, these cancel out, and I get 11. Then I'm going to add, I'm subtracting here, so my inverse operation is adding. And I get 2n less than or equal to 12, divide by 2, and I get n is less than or equal to 6. So in order to graph that on my number line, I'm going to do a solid dot because I've got that equal sign. I do a solid dot, and n has to be smaller. So what numbers are smaller than n? 5 is, 4 is, 3, 2, 0, 1. All of those numbers are smaller than n. Okay? Alright, let's stop this and we'll go on to video 3.